Hello and welcome to this biotechnology webinar brought to you by Nova BioProfile and Sartorius. Today we have a presentation from Kymab, a therapeutic antibody development company based in Cambridge, UK. The presentation entitled Data-Rich Cell Line Screening, Leveraging ambr15 Cell Culture and BioProfile FLEX2 Integration will be delivered by Rahul Pradhan, a senior scientist with over 10 years industrial experience in bioprocessing. Rahul currently leads upstream cell culture development activities at Kymab, which involves process development, optimization, and tech transfer to GMP. This presentation will provide a case study from Kymab, which shows how the integration of the ambr15 microbioreactor system and the FLEX2 cell culture analyzer can assist in improving antibody productivity, workflow efficiency, and reduce project timelines. My name is Royston Bowman, Applications Manager at Nova Biomedical, and I will be taking your written questions for the Q&A segment at the end of the webinar. If you have any questions for Sartorius, I'm also joined by Sunil Chatra, Product Champion for the ambr system. A recording of this webinar will be available on the Nova Biomedical website if you need to share it or listen to the presentation again. At this point, I'd like to hand over to Rahul.
Thanks very much for the introduction, Royston. So today I'll be talking about data-rich cell line screening by leveraging the integration between the ambr15 and BioProfile FLEX2. I'll start off by briefly talking about microscale systems in bioprocessing. Then I'll dive into the Kymab case study covering a manufacturing cell line selection campaign, and then conclude with a summary. Within the biopharmaceutical industry, various microscale systems are often used for screening and optimization studies, and these can include things like small shake flasks, pin tubes, plates, and scaled-down bioreactor systems. Now, limited sample volume is a key consideration for these systems. There has to be a balance between samples taken for in-run analysis versus preserving the vessel contents for product quality analysis. And there are significant challenges to obtain a full profile of offline data. Some clever sampling strategies are often put in place to get around these challenges, and things like sacrificial duplicate vessels are often used. Additionally, a combination of different analyzers with different sample volumes is often needed. For example, we might need a BGA for pH and gases, a nutrient analyzer for metabolites, and a separate cell counter for getting cell density and viability data. Also, further efforts are then needed to make decisions based on this offline data and then feed it back to the running experiment. All of this adds a lot of operational overhead in terms of the scientist's time, and also it has the higher probability of introducing errors. Now, the integration of the BioProfile FLEX2 with the ambr15 aims to resolve some of these issues. So the ambr15 is one of the more advanced microscale bioreactor systems that's available. It offers a full suite of process controls such as pH, DO, and gassing, allowing the generation of data more representative of a larger scale bioreactor system. It has a liquid handling robot and a good software interface that allows the creation of sophisticated sampling and nutrient feeding strategies. It also has limited online analyzer connectivity available. For example, a cell counter can be integrated with the ambr15, and there's also an analysis module that does offline pH measurements. But most offline data, such as glucose, lactate, etc., has to be manually imported into the system. And it's quite difficult to generate a complete set of offline data. The BioProfile FLEX2 is a nutrient analyzer that provides metabolite, gas, and cell density analysis. It has low sample volume requirements and runs on a sensor card-based technology with very limited maintenance. But importantly, this can be integrated with an ambr15 using an external sampling module or ESM. And this allows the automated feedback of analyzed data directly into the ambr system. Now I'm going to dive into the Kymab case study covering a manufacturing cell line selection campaign. This cell line selection campaign was for a Kymab novel monoclonal antibody fusion molecule. The campaign aimed to select the final manufacturing cell line and involved research cell bank or RCB screening, process scale-up to 3-liter benchtop and 30-liter single-use bioreactors, and also included a phenotypic stability evaluation to assess cell line suitability for long-term manufacturing. This slide summarizes the data from the RCB screen. During this screen, the top 24 cell lines were transferred in from the cell line development group and evaluated in duplicate using the ambr system. All the vessels were sampled daily to generate a full profile of offline parameters. Most of the data that you can see here is from the FLEX2, but we also have data from the ambr15 such as vessel volume and base volume, and the tighter data is from the Kymab analytical team. All of the offline data that we saw in the previous slide from the FLEX2 is automatically imported into the ambr software, as you can see from the table here. And these parameters can then be used in equations for various feedback loops. Obviously, to enable this, you'll need to invest some time in terms of ambr15 programming. But once that's done, there can be significant time savings for end users, as no manual import or manipulation of data is required. And this means that it is possible to minimize and simplify weekend and out-of-hour working. So this slide pulls out some key data for the top 6 RCB clones, and the data for each clone is in rows. As you can see, we saw very good correlation between the replicate conditions in terms of cell culture, titer, and metabolic profiles. There were some variations in terms of CO2 and base addition levels. During this experiment, we implemented an automated glucose feedback control loop for all vessels. Also, the nutrient feed rate was based on viable cell density and the glucose consumption rate. This was updated every day based on the offline data coming in from the FLEX2. And by using this system, we were able to fully reproduce the bench scale or larger bioreactor style feed profile control. This slide zooms in on data for clone 2. As you can see, the replicate ambr vessels for this clone show very comparable cell growth, titer, and other metabolic profiles. We did see some differences in things like glucose values, vessel volume, and base volume, and this was linked to process feedback control. The next stage of the cell line selection campaign involved process scale-up. Based on cell culture and product quality data, clone 2 was selected for scaling up to supply materials for development studies. The process was scaled up to 3-liter benchtop and 30-liter single-use bioreactors. Some potential risks for scale-up were identified based on the ambr data and the availability of the full panel of metabolites, pH, and PCO2 data from the FLEX2 during the RCB screen allowed for strategies to be put in place to mitigate against some of these issues. So I'm going to talk about a couple of the scale-up risks and the mitigation strategies that were put in place. One of the major scale-up risks that we were able to identify was high PCO2 levels during the RCB screen. Now, this was possible due to the availability of the full profile of PCO2 data. Now, if you look at the top two charts, the left-hand side chart shows the online ambr pH, and the right-hand side top chart shows the corresponding sample FLEX pH data. As you can see, we had very good pH control between the replicate conditions, which meant that the high PCO2 levels that we observed weren't an artifact of malfunction in pH sensor spot. Now, PCO2 levels typically tend to go up as the process is scaled up, and this can cause a reduction in your product titer and cell viability. During the RCB screen, we saw a spike in ammonium levels after day 10, indicating cellular stress. There is some literature out there suggesting that high PCO2 levels can cause mitochondrial dysfunction and affect the internal cellular pH. So to mitigate against these high PCO2 levels, a gapping strategy was defined to maintain the PCO2 levels between 40 to 100 millimeters of mercury, and this strategy was applied to the 3-liter benchtop and 30-liter single-use bioreactors. And the second scale-up risk that we identified was high endopterin lactate levels. As you can see from the top left chart here, the lactate levels for clone 2 spike up after around day 13, and this causes a lot of base to be added to the vessels. Now, high lactate levels, especially towards the end of a bioreactor process, can negatively impact cell viability and complicate harvest operations. Now, to mitigate against this risk, further process development activities were undertaken. This slide shows a summary of the scale-up data for clone 2 overlaid with the previous ambr data. Now, the ambr data is shown in yellow, while the 3-liter benchtop bioreactor data is shown in blue, and the 30-liter sub data is in green. The optimized gapping strategy was applied to both the 3-liter and 30-liter bioreactors. And by doing so, we were successfully able to control the PCO2 levels between 40 to 100 millimeters of mercury. And by proactively controlling the PCO2 levels, we were able to reduce the ammonium levels by around 50% compared to the ambr bioreactors. During the scale-up, there was some variation between the replicate conditions for the 3 and 30-liter bioreactors. For example, we had some minor pH probe issues for one of the 3-liter replicates, and this caused a bit of cell growth lag towards the early part of the process. Also, the final titers for the 30-liter subs were lower compared to the ambr and 3-liter bioreactors. Now the profiles for titers tracked really well till day 12, but after that we had really large amounts of base being added to the 30-liter bioreactors compared to the ambr and 3-liter bioreactors. Now this was linked to lactate levels and the pH control of the bioreactor system. Now the early availability of the full panel of PCO2 data during the RCB screen was a big advantage for us, as we were able to scale up to a 30-liter bioreactor much earlier than we would have normally done. Now this slide compares the ambr and scale-up data from the previous slide, now referred to as process 1, against an optimized process condition referred to as process 2 and shown in pink. Now process 2 was developed to mitigate against the high end-of-run lactate spike that was seen with clone 2. Now if you look at the lactate chart in the bottom row, you can see that the 3-liter benchtop run using process 2 shows a much lower end-of-run lactate level compared to the corresponding process 1 conditions. Also, we were able to significantly improve the product titer by using this new process. Now, the optimized gassing strategy developed during scale-up was also applied to the process 2 condition, and by doing so, we were able to proactively control PCO2 between 40 and 100. The final study undertaken during the cell line selection campaign was a long-term manufacturability assessment, also known as the phenotypic stability study. This study aimed to ensure cell line suitability for long-term manufacturing by identifying and evaluating any changes in cell culture and product quality attributes at different cell generations. The phenotypic stability study is quite important as you don't want your cell culture or product quality attributes to change as the cells age during inoculum train expansion. For this study, the top 6 RCBs were run in ambr at different cell generations. Both process 1 and 2 were evaluated with duplicates for each time point. Also, the optimized gassing strategy developed during scale-up was also applied to the process 2 ambr bioreactors. This slide summarizes the phenotypic stability data for clone 2. We have the data from the process 1 conditions on the left and the data from the process 2 conditions on the right. The early generation bioreactors are shown in blue while the late generation bioreactors are shown in green. The replicate conditions for early and late generation cultures showed a really good correlation in terms of cell culture data, and this was seen across both bioreactor processes. We did see some differences in product titer between the early and late generation cultures, and this was expected as expression levels decrease with cell age. Also, the process 1 and 2 ambr data is broadly in line with the previous scale-up data in terms of both cell culture and metabolic profiles. The implementation of the optimized gassing strategy for process 2 greatly improved the consistency of the PCO2 profile across the replicates, while a larger variation was seen for process 1. And you can clearly see this by looking at the PCO2 chart in row 3 for both conditions. The last 2 charts in the bottom row for both processes show the purity and glycosylation data. You can see that this data was really consistent across the replicate condition and also between the different cell generations. And this was observed for both bioreactor processes. This data was really positive and helped us to select clone 2 as our lead cell line. In summary, the integration of the ambr15 with the BioProfile FLEX2 allows the generation of a full panel of offline cell culture and metabolite data, which was previously quite difficult with a microscale bioreactor system such as the ambr15. Now, this should help bring microbioreactor systems more in line with larger scale bioreactor systems. Also, the seamless interconnectivity between the ambr15 and FLEX2 should simplify the implementation of complex process controls in the ambr. Now, due to the availability of all this data, potential process issues can be identified quite early on in a manufacturing cell line selection campaign. And de-risking studies can then be initiated based on the ambr15 and FLEX2 data. Now, the availability of this enriched dataset due to the integration of the ambr15 with the FLEX2 has enabled Kymab to select a cell line suitable for larger scale bioreactor manufacturing a lot earlier. And this has benefited project timelines and also simplified material supply for development and preclinical studies. In closing, I'd like to acknowledge the cell line and analytical development teams at Kymab. I would also like to thank Nova Biomedical and Sartorius for enabling this webinar presentation. Finally, I'd like to thank all the audience attending the webinar and hand over back to Roystein for the Q&A session.
Thank you very much, Rahul, for sharing that very interesting presentation and for sharing your experiences of the integration with us. We've had a number of interesting questions that have come through during the course of the webinar. I'd like to begin with one question about the integration specifically. When the analyzer is connected to the ambr15, are you able to run any other samples on the system?
So yeah, you can actually run samples while the ambr is hooked up to the FLEX2. Obviously, when the ambr is sampling, the FLEX will be busy and you can't run a sample. But in between samples, yes, the FLEX is fully available for any other samples.
Okay, thank you very much. We have another question here about the feedback control loops. Is the feedback control hard-coded into the process steps, or is it entered manually based on glucose measurements?
So for this experiment, the feedback loop was actually hard-coded into the experiment. But obviously, during the clone screen process, depending on the glucose consumption rate, we were tweaking it. But as we get more process data for a specific clone,
Thank you very much for that, Rahul. There's a question about viabilities. Some of your clones had viabilities near or below 90% on the day of inoculation. Is this ambr15 induced, or do you also see this phenomenon at scale?
So I would say this is actually an artifact of the actual cell line. It's not directly linked to the ambr15. We did see this when we scaled the process up. One thing to keep in mind is that this was a clone screening experiment, so all the cell lines behave slightly differently. But I think for our lead clone, most of the viabilities typically are close to 95% or above.
Thank you very much, Rahul. I have a question here on product quality. Did you compare product quality in ambr versus the 3-liter and the 30-liter?
Yeah, so I haven't shared that data with you guys, but yes, we did compare product quality between the different scales, and it was all found to be comparable.
Good. I have a question on gassing. How often were you measuring offline samples using the FLEX2?
If you're referring to the actual offline samples for the ambr vessels, we were taking a pH sample almost every day. There could be that when we missed a day or two, but mostly we had almost 15 pH samples in the course of the run.
Okay, thank you. A question about glucose feed. Were you only feeding the glucose, or were there any other parameters?
Yeah, this was a fed batch process, so there were various other feeds that go into the process on top of glucose.
Sure, understandably. Did you factor in the volume changes in ambr compared to manufacturing bioreactors for the study?
So we run all of our ambrs as scaled-down models of a larger system, so yes, that was factored in.
Okay, thank you. Just going through some more questions that we have. So we have a question about the implementation at larger scale. I'm just going to read this out. So I'm keen to implement this at our large reactors up to 2,000 scale. Does the distance from the reactor to the Nova, that is the FLEX2, affect the sample data reported?
No.
Yes. So this is a question for Nova Biomedical. We do have a set length from the analyzer to the ambr system. So if you're working with an integrated analyzer, we're looking at a maximum of roughly about 30 centimeters between the ambr system and the analyzer itself. Okay, moving on. How much time was necessary for programming? This is in terms of in-house FTEs or full-time employees. And how much did Nova assist there? So this is with regard to the implementation. Did it take a considerable length of time?
In terms of the setup of the integration between the ambr15 and the FLEX2, Nova did come on site initially to make sure that our data was more comparable to our offline cell counter analyzers and other systems. So yeah, during the initial integration, the support from Nova was pretty good.
Thank you. And we have a question about the sample volume. What sample volume are you acquiring from the ambr system?
Anything between 400 to 450 microliters.
Maybe I can comment on that. So there's 3 settings that are available on the system. It can be set to 400 microliters, 450 and 500. I assume you have it set to 450. Did you feed the same composition to all clones? Unfortunately, Rahul is not able to answer that. But thank you very much for your question and for the interest. I have a question regarding cell counting on the Nova FLEX2. Were you able to establish good comparability between the FLEX2 and the in-house cell counter? This would be any reference cell counter that you may have.
Yeah, so before we did the integration of the two systems, we went through a whole process of comparing the data that was acquired from the ambr systems via the ESM module with the cell counter that we have in-house. And we also compared offline measurements which were done without the ESM on the FLEX2, and we reached, and Nova can help you with that process.
Sure, thank you. I have a very interesting question here regarding the gas concentrations. So are gas measurements on the FLEX2 reliable considering the flow path from the ambr to the FLEX2? For your PCO2 values?
PCO2 values. Yeah, so if you see from some of the webinar slides, pretty much the data was quite reliable, and when we ran the large-scale bioreactors, most of our things like the pH and PCO2 matched quite well with the ambr system, so I'm pretty happy with the correlation. Okay,
thank you. Did you sample every day for the Nova analysis? Sample frequency?
Yeah, so we did sample every day, but I should say that sometimes we might have done, the pH sampling, for example, could have been done every other day, or we might have missed a day or two. But yeah, most of the samples were every day.
Okay, so this is probably a question for Nova Biomedical. Does the FLEX2 have IgG measurement? No, the FLEX2 does not have IgG measurement. That was available on the predecessor device, the BioProfile FLEX. So another question for Rahul. What did you do to reduce ammonium levels later in the culture in larger bioreactors? I'm not sure if you can comment on that.
I can't go into the details, unfortunately. As you can see, we optimized some of the gassing strategy and other parameters, but beyond that, I can't really go into it.
Thank you very much for your question. Unfortunately, Rahul is not able to comment on that. Another question for Nova. How long does it take for the vessel to be sampled to the moment the results are obtained? So that is 6 to 7 minutes from sample acquisition to the data appearing on the ambr computer. Okay, just scrolling through the questions again. Is there a feedback loop where the FLEX2 can feed values, i.e. pH or glucose values, back to the amber system?
Yeah, absolutely. And as you find some of the data, we implemented both of these feedback strategies. And yeah, you can have most of the parameters in various equations that you want. Yeah.
And now that we're talking about feedback loops, I'd like to include Sunil, who is the product champion for the amber system. Could you give an overview on how the feedback loops could work with the equations and the variables?
Yes, so within the ambr15 we have an equation editor that allows you to develop fairly complicated equations as per your requirements. So you can include properties such as specific growth rate, glucose consumption rate, or consumption rate of any particular metabolite that you want to control. You can use the value from the analyzer, feed that into the equation, and get the amber to automatically work out how much of a feed, for example, that needs to be added. You can also use, for example, if expressions, similar to the if expressions you see in Excel, in order to try and bound the amounts of liquid that are added. So to try and ensure that you don't add too much or too little, you can restrict the amounts that go through by applying suitable if expressions within the equation editor. And that's something that I see quite a few customers using when they run equations on the ambr15.
Thank you very much, Sunil. That was really useful to know. A question for Nova. Is OPC module necessary for connectivity between FLEX2 and amber? No, OPC is not required for connectivity between FLEX2 and amber. I have another question regarding the sampling for you, Rahul. If you sampled every day, did you have a problem with the volume in the vessels?
No.
So this didn't affect the
no,
culture?
it did not. Yeah, no. So we run our systems at a scale down, for larger vessels, so it did not impact our volume.
Thank you very much. Just moving through the questions. We have a question on the whether you saw a difference in the lactate and ammonium levels for different clones. Literature maintains that as a major factor, I assume that all the amber saw similar stress, assuming similar process conditions. I'm just reading the slide. This is common in mammalian cell cultures, so I wanted to see if you could discuss. Are you able to elaborate on this, Rahul?
I guess I could just make a small point. I can't go into too many details, but these were unique clones. These are monoclonal cell lines, so you would expect them to be slightly different. And even though they would experience the same process within a bioreactor, at a cellular level, each cell line is slightly different. So you would expect them to behave or react differently to the process. So I'm not totally surprised that we saw different profiles between different clones.
Thank you very much for that. So we have a question, FLEX2 having the gas module, do we still need to install the pH and gas on the ambr15 for pH offset? Sunil, are you able to comment on that?
Yes.
I can provide some comments as well.
So with the ambr15 you can choose either to have the FLEX or the analysis module or both, and you can choose which one you want to use in order to carry out the pH recalibration. It's entirely up to you. In fact, with the ambr15 you can integrate all three types of analyzers, the FLEX, the analysis module, and the ViCell or the CZEX cell counter, if you so wish. And again, you can choose which of the analyzers you want to rely upon in terms of the cell count. Whether you want to use a ViCell or you want to use the FLEX reading, you can decide what you want in terms of that.
Thank you very much for that, Sunil. A simple question for Rahul. Was this a fed batch or perfusion process?
This is a fed batch process.
Thank you. So we just have a few more questions coming through. Are there any major engineering considerations for the Nova Flex integration with ambr15? Did you have to redesign your laboratory? Let's start with you, Rahul.
Yeah, so you need to consider, where all the different pieces of equipment are going to go. And so before you buy the kit and it arrives in your lab, I would expect that you make appropriate arrangements for that. But yeah, you can chat with your Sartorius and Nova reps, and they can kind of make suggestions and help you out with the locations of various kits, etc. as well. For example, the FLEX2 always has to be on the left-hand side of the ambr. So if that's the consideration, you need to make sure that you design your lab appropriately.
Yeah, thanks. And from our side, they're both benchtop systems, so there aren't really any significant alterations that would be required. As mentioned previously, OPC is not required for the connectivity, so the systems are pretty much plug and play. If you have an existing ambr15, we only need to install the sample cup and the ESM for the FLEX2, which is the external sampling module, and in which case it's ready to take samples directly from there. And as rightly mentioned by Rahul, you do have to consider that it only is connected to the left-hand side, so there must be room on the left-hand side of both an ambr15 and an ambr250. Sunil, is there anything you'd like to add to the engineering requirements for the integration?
Not specifically, no. I mean, the Nova Flex is purchased separately from the ambr15. So what typically happens is a customer would purchase the Nova FLEX2, it would be installed and commissioned by Nova Biomedical, and then Sartorius would come along and perform the final hardware and software hookup to make sure the two systems spoke to each other.
Thank you very much. So we have one more question that's come into the inbox, and that's regarding the ambr250. Is it possible to integrate the ambr250? Yes, it is.
Yes, you can integrate all the different types of analyzers. The ViCell, the CDEX, the pH analysis module, and the Nova Flex can all be integrated in any combination that you want on an ambr15 cell culture or onto an ambr250H2.
I think we have time to squeeze in one more question before our time runs out. That's just come in just a second ago. If you are sampling every day from the ambr15, if the process is on day 15, what is the total? Approximately 6 ml? What's your initial volume 15?
Yeah, so if you scroll back to some of the webinar charts when you get a chance, yeah, so we started off at the 15 ml working volume of the ambr system, and depending on the different feeds, etc., which went in, we ended up somewhere between 10 to 13 mils at harvest, or even larger for some vessels, depending on what went in.
It's also worth bearing in mind when we teach people how to use the ambr15, we always supply them with a little Excel spreadsheet, which allows you to enter the volumes of feeds, the volumes of samples, expected base volume, and so on and so forth. And we always train people to design their ambr15 scripts in such a way that they will ensure the working volume remains between the 10 to 15 milliliter normal operating range.
Well, thank you very much for the presentation, Rahul. That was very interesting, your experiences with the integrated system to the ambr250. It definitely shows some of the benefits of having an automated analyzer connected to that, in addition to the pH offset capability. And could I also thank Sunil for your comments from the Sartorius side as well. And with that, we would like to end